Our general scope is to introduce EEG biomarkers in the research framework of the National Institute of Aging and Alzheimer's Association, the guidelines by Jack and colleagues in 2018. You can see in the slide the amyloid, tau, and neurodegenerative biomarkers used in the research framework. And we are working to convince the people to introduce EEG biomarkers between the biomarkers of tauopathy and biomarkers of neurodegeneration. Amyloid and tauopathy are based on biomarkers of cerebrospinal fluid and positron emission tomography. And the neurodegenerative biomarkers are based nowadays on anatomic magnetic resonance imaging and fluorodesoxyglucose positron emission tomography. Ideally, EEG biomarkers of brain functions could detect patients with Alzheimer's disease and Lewy body diseases from preclinical stages without cognitive symptoms or clinical manifestations to dementia. Among EEG biomarkers, we used the EEG activity related to the resting state condition of eyes closed and open. It's a very easy and a diffuse approach to study neurophysiological mechanism of vigilance. EEG alpha rims of quiet vigilance were introduced by Hans Berger in the beginning of the last century. You can see in the red framework the EEG activity recorded during eyes closed resting state condition. You can see the alpha rims, ample oscillations in the posterior areas at the frequency of about 10 Hz. During event-related activity, the alpha rims disappear and you can see the beta rims emerging in the EEG traces. The EEG alpha rims in the resting state are prominent in the posterior scalp regions and the posterior cortical areas. They reflect cortical inhibition in relation to no visual stimulations or auditory stimulation and psychophysical relaxation. In the slide, you see the model of cerebral cortex and thalamus, which may generate EEG activity and alpha rims. This model was validated in animal models with electrodes implanted in the cerebral cortex and in the thalamus. The EEG alpha rims may be generated by reciprocal loops between thalamus and cerebral cortex, modulated by ascending activating system, particularly with using acetylcholine as a neurotransmitter. So alpha rims may reflect a traffic light function of this thalamocortical loop. EEG activity is a complex signal that can be decomposed in elementary oscillations at different frequencies. And this allows to identify the individual alpha frequency peak the specific frequency in the alpha range showing the maximum amplitude. And you can see in the slide how you can represent the amplitude of the power of single EEG oscillations in the EEG power spectrum. So what do resting state EEG RINs tell us about Alzheimer's disease and Lewy body diseases? In our studies, we addressed the hypothesis that resting state EEG markers may reflect cortical neural synchronization in a different way in Alzheimer's disease and Lewy body diseases, and that the resting state EEG markers may be related to disease clinical manifestation of these diseases. Our general approach is based on the recording of a resting state, eyes closed and eyes open conditions with the 1020 electron montage system using 19 electrodes. So it's a low resolution for the EEG activity. And we used artifact-free EEG periods as an input for exact low rate freeware, allowing the estimation of cortical sources of EEG rings. You can see that we used large regions of interest in relation to this low resolution of EEG recordings. This is the consortium Pharmacog, a European consortium investigating the biomarkers of Alzheimer's disease in patients and animal models. Some studies were performed within the framework of the Pharmacog project. The first study of the Pharmacog project I present today is related to the validation of resting state eyes closed EEG biomarkers in alpha and delta RINs in relation to Alzheimer's disease neuropathology as revealed by cerebrospinal fluid, A beta and phospho-tau biomarkers. We compare the EEG source activity in Alzheimer's disease patients with mild cognitive impairment as opposed to mild cognitive impairment patients not due to Alzheimer's disease. You see the sources and the activity of the sources for different frequency bands in the horizontal axis, the intensity of cortical activation in the sources in the vertical axis. In the red, you have the power spectra of source activities for Alzheimer's disease and mild cognitive impairment. And in blue, you have the same spectrum of cortical source activity for MCI people not due to Alzheimer's disease. You can see that even the two groups show the same cognitive impairment. You have a difference in the source activity, especially in the alpha RIN, in parietal, occipital, and temporal areas, with significant effects in the parietal and the occipital areas. Another effect can be seen in the delta source activity in the temporal areas. In general, you see that Alzheimer's disease patients with mild cognitive impairment show lower alpha source activity as opposed to MCI patients not due to Alzheimer's disease. So the general level of posterior cortical inhibition in the resting state eyes closed condition is different in these two groups of patients. Another validation of resting state EEG markers was performed by the correlation between global EEG source activity and brain hypometabolism biomarkers of positron emission tomography. The study was performed in Alzheimer's disease patients with dementia, and you see a significant correlation between global delta source activity and the brain hypometabolism. The higher the delta source activity in the cortical sources, and the higher the brain hypometabolism in the typical regions related to RD neurodegeneration. In the same line, we validated EEG biomarkers during the resting state condition and the cortical gray matter volume in MCI and dementia patients with Alzheimer's disease. You see in the graph that the higher the global delta source activity and the lower is the cortical gray matter volume, as revealed by structural magnetic resonance imaging. In contrast, the higher the alpha source activity in the cerebral cortex, and the higher is the cortical gray matter volume. So in both cases, we have a nice correlation, significant correlation between delta and alpha source activities and the cortical gray matter volume, as revealed by magnetic resonance imaging biomarkers. Of course, you can see variability at the individual level. Any circle here is a subject, but anyway, there is some statistical correlation between these variables. And these are the European funds supporting this research. Thanks a lot for your attention.